Good evening. So in this video, I'll continue talking about logic gates. So for instance, if you have an AND gate that looks like this, basically it has one input. We can call it A. So the way we read this, basically it's ending, this AND gate is ending A with itself because you have a junction point here. So you have A or A and A. So A and A, which is just A, as we will see. Then, so I'll call that 1. So example 2, we have an AND. So that takes one input again. So if we call it A, so basically the way you would read this, so we have A here and A with it. So A is ANDed with itself. So from example 1, this is equal to A, but since it's inverted, we'll put a bar on top. That is, if A is equal to logic 1, then A naught or A bar would be 0. So you would just invert it. So 3, just another example. And again, this here, you can put A ANDed with itself, which is just A bar. So 3, if I have an NAND gate, so I have A and logic 1. So you have A and 1 with a bar on top of it, which is just A bar or A naught. So 4. So if I have a NAND gate that takes, say, like X and Y inputs, so obviously the output of this would be X and Y bar because we have this inversion here. And this is fed into another NAND gate, so like another NAND gate. So you have inversion here. So the way basically as if you have X and Y here. So it's two inputs, but it's the same value basically. So then the output would be so you would add another bar, which is just X and Y, because if you have two bars, that means it's removed. The negation is no longer existing. So that was it for this video. Thank you.